Stokes' law. Stokes' law deals with the force of viscosity acting on a spherical body which is moving through a fluid. This is the spherical body. It is moving with velocity v through a fluid. Then the liquid layer which is in contact with the spherical body, that is also moving with the same velocity v. Now the layer just below this one, it will move with some less velocity. This is more less, more less. Similarly, in the upper side, velocity of this layer will be little bit less, more less, more less. That means here one layer opposes the movement of other layer. That means that force is known as, that opposing force is known as viscous drag or force of viscosity. This layer will oppose the movement of this layer. This is the force of viscosity which is acting along the opposite direction to the direction of movement of the body. Then this force of viscosity depends upon some factors. First one, it depends upon coefficient of viscosity. Let it is directly proportional to eta to the power a. Eta is coefficient of viscosity. And second one, this force of viscosity depends upon radius of this spherical body, r to the power b. Another factor is there, it depends upon velocity with which the body is moving, the velocity with which the body is moving through the fluid. Then by combining these three relations, we can write eta to the power a, r to the power b and v to the power c. Then by dimensional analysis, you can solve it. F is equal to k eta a r to the power b v to the power c. By dimensional analysis, find out the values of a, b, c. Then you will get k eta r v. Value of a, b, c is equal to 1. Now, by experiments, it has been observed that the constant is equal to 6 pi. F is equal to 6 pi eta r v. So, this is mathematical form of Stokes' law. That means Stokes' law deals with the force of viscosity acting on a spherical body when it is moving with some velocity through a fluid. Is it clear? Now, I will discuss about terminal velocity. What is that one? Let it is a spherical, it is a body of any shape. Okay, it is coming down through a fluid. Fluid means it may be liquid, it may be any gas. Clear? Now, the body is coming down with velocity, uniform velocity, remember, not with acceleration due to gravity. With uniform velocity, it is coming down. Clear? And in this case, the different forces acting on the body are weight. It always acts in the vertically downward direction. The fluid through which the liquid is coming down, that fluid will always give upward force, that is upthrust. Upthrust is given by the fluid always in the upward direction. As the body is coming down, force of viscosity will act in the upward direction. Just I told that force of viscosity acts opposite to direction of movement of the body. So, that force of viscosity F, it is acting in the upward direction. I told it is coming down with uniform velocity. That means dynamic equilibrium. It is an example of dynamic equilibrium. So, in equilibrium condition, I can write U plus F is equal to W. Clear? Now, let rho, it is the density of body, and sigma, it is density of fluid through which the body is coming down. Sigma density of fluid, rho density of the body. U upthrust. Okay, upthrust means volume of the body. Upthrust is given by fluid, density of fluid into G. And force of viscosity by Stokes law, just now I have got, it is 6 pi eta r. V is velocity. Weight is equal to m into g. Mass, density of body, rho. Mass density into volume into g. What is volume? Volume of this body, spherical body we have taken. Volume is 4 by 3 pi r cube g. So put this value of W here. 4 by 3 pi rho r cube g. Clear? Then solve it. We are going to find out this uniform velocity. Clear? Then after solving it, you will get V is equal to 2 by 9 r square rho minus sigma into g divided by eta. So this uniform velocity is known as terminal velocity. Okay. Now the opposite one also may happen. The body is moving up. Under what condition it will happen? Look here, let me tell one thing. Body is coming down means density of body must be greater than density of the fluid. Okay, because if density of the body is more, the body comes down. Now in the opposite case means second case, the body is moving up with uniform velocity v. Okay, it means density of the body is less than the density of fluid. Density of the body is less. What are the different forces acting on it? Weight always acts in downward direction. Upthrust always in the upward direction. Okay? Fluid gives upthrust on the body in upward direction. Body is moving up. So, what is the direction of force of viscosity? Force of viscosity is acting in downward direction. It is moving up with uniform velocity means total downward force will be equal to upward force. That is, I can write F plus W is equal to U. Just like the previous one, put the value of F, W and U, you will get terminal velocity 2 by 9 r square. Here it will become sigma minus rho, as sigma is greater than rho. So sigma minus rho divided by eta. Okay. Now this is important. You know that the paratroopers are coming down from the helicopter by using a parachute, and they are hitting the earth's surface, okay, with a fixed velocity, that is the terminal velocity. Okay, they will not fall down with any acceleration. They will fall down, they will come down with uniform velocity, and that velocity is very less. As a result, they don't get hurt. Is it clear?